All right, welcome back, class. This is Algebra 1, 7.4. We're solving inequalities in multiple or many steps. Today, it's pretty simple. We're going to start somewhere that we already know, and that is in the equations. Let me give you an example. Let's say I had this equation. 3x minus 6 is equal to 9. We're trying to figure out what this one variable is equal to, such that if I replace that variable with an actual number, it will produce for me 9. How do I do that? Well, I know from early days in, I don't know, pre-algebra, that there's something called PEMDAS, right? And PEMDAS tells us the order we should do our operations in. So first you do the parentheses, then the exponents, whichever one comes first, from right to left, multiplication or division, and then whichever's left, addition and subtraction. That's usually what we used to do. Now what we're going to do is we're going to do PEMDAS, but in reverse order. So I start here at the bottom, and I say, all right, first I check for addition and subtraction. Is there an addition or subtraction situation going on here? Yes, there is. There's a -6. So I need to do the inverse operation of subtraction, which is addition. So -6, I'm going to add 6. What I do to one side of an equation, I must do to the other. So now I have 3x, -6 plus 6 is 0. I don't need to write it again. Equals 9 plus 6, and 9 plus 6 is 15. Okay. Now I have what, or 3 times what is equal to 15. So I've already done my addition and subtraction, so those are done. Let's cross those out. Now I go one more up. Is there multiplication or division? Yes, there's multiplication, 3 times x. What is the inverse of multiplication? Well, it tells us right here, division. I divide by the 3, because I'm trying to get the x by itself. What I do to one side, I must also do to the other to keep it balanced. 3 divided by 3 is 1. So I'm going to have a 1 times x on this side, and 15 divided by 3 is 5 on this side. Now I can simplify that further. 1 times x, 1 times anything is just x or itself. So 1 times x is x. And nothing happened to the 5. Therefore, I get x is equal to 5. If I plug that 5 back into my original equation, do I get a 9? Let's remove the x and place a 5. So 3 times x is now 3 times 5. 3 times 5 is 15. 15 minus 6 is, in fact, it is 9. So 15 minus 6 is indeed 9. Does 9 equal 9 on both sides? Yes. Therefore, my x is equal to 5. And all I had to do was do the reversed order of operations, their inverses, to find out what the variable was. So now we're going to do the exact same problem, but this time we're going to do it with inequalities. So let's rewrite that whole problem and see if you can figure out the solution to the inequality. Clean up everything here. All right. So the inequality would be 3x minus 6 is greater than 9. Okay? So 3 times some number, take away 6, is, less than 9. I misspoke, less than 9. All right, so I do the exact same steps then. First, I check my addition and subtraction. Is there addition or subtraction? Yes, there is. There's a -6, so I do a +6. You're going to notice it's the exact same steps, and that's the idea. We're going to end up with a 9 plus 6, which we know is 15. I'm going to go a little faster because we already did this. 3x less than 15. How do I find out what the x is by itself? I now move up to multiplication and division. I have multiplication. Its inverse is division. What I do to one side, I do to the other. 3 divided by 3 is 1, so I get x. times 1 is less than 15 divided by 3, which is 5. 1 times x is less than 5. Or more precisely, whatever number I choose for x, it must be less than 5 for it to work with this equation, or this inequality. So let's pick a number that is less than 5. Let me draw my number line. I have 0 here, I've got 5 over here. It is not equal to 5, it is less than 5, so it's all the numbers to the left of 5. All of those are less than 5. A number that is less than 5 is 0. I'm going to try 0. 3 times 0 minus 6. Is that going to be less than 9? Well, 3 times 0 is 0. 0 minus negative 6 is just negative 6. Is negative 6 less than 9? Well, 9 is right here. Negative 6 is over here. Yep, looks like it. It's true. Therefore, my answer is correct. X must be less than 5. Whatever you choose for x must be less than 5. And that's it. I have my solution and my graph. Let's try another one. Let's see. Negative 5 times a plus 2 is greater than or equal to 22. All right, I write my PEMDAS out here just so I know what to track. Start at the bottom. All right, do I have addition or subtraction? I do, the positive 2. The opposite of positive 2 is negative 2, or the inverse. Let me clean this up. I get negative 5, nothing happened to it. 2 minus 2 is 0, I don't need to write it again. Drop the sign. 22 minus 2 is 20. All right, this is what I have so far. Negative 5 times a is greater than or equal to 20. Now I need to check my multiplication and division. I have multiplication, negative 5 times a. The opposite, therefore, or the inverse, is division, negative 5. I divide by negative 5. I notice that I've divided by a negative number. When I have an inequality and I divide by a negative number, I instantly must rewrite and switch. Switch the sign. The sign now switches to greater than, or just switch it to the other side. 20 divided by negative 5 is negative 4. Negative 5 divided by negative 5 is 1, positive 1. 1 times a. All right, 1 times a is just a. A must be less than or equal to negative 4 for this original equation to be true. Let's pick a number that is less than negative 4. Let me draw it out. I got 0 here. I got negative 4 over here. It can be equal to it, or it also could be less than. So I have my closed dot. A number that is equal to negative 4 is negative 4. Let's just plug that in. So now I'm going to rewrite my original equation. Negative 5 times a plus 2 is greater than or equal to 22. If I replace my a with a negative 4, I'd get negative 5 times negative 4 plus 2. All right, let's clean it up. Now I just do regular order of operations. Any parentheses? No. Oh, actually there is. This negative 5 times 4, which is multiplication. Negative 5 times 4 is positive 20. A negative times a negative. Let me drop the plus 2, the greater than or equal to sign, 22. Now I do addition. 20 plus 22 is 22. Is 22 greater than? No. 22. But is it equal to? Is it equal to 22? It is. Therefore, it works. Our answer seems to work. A is less than or equal to negative 4. Nice. All right, let's do one last one using division. Okay, so I've got Some number divided by 4, negative 4, plus 3 is less than 0. All right, all I need to do is write out my PEMDAS so I can track what I'm doing. All right, I start at the beginning and I say, all right, is there any addition or subtraction? Well, yes, there is. There's addition, the plus 3. What's the inverse of plus 3? It's minus 3. What I do to one side, I must do to the other. That's going to leave me with m divided by divided by negative 4. 3 minus 3 is 0. I don't need to rewrite it. Is less than negative 3. 0 minus 3 is negative 3. Now, some of you like to solve this using the fractions, but if you were watching the last video, you noticed that it's easier to rewrite this as m divided by negative 4. Just write it out long ways, is negative 3. That way I can just do this. I check my next step, multiplication and division. There is division. The opposite of division is multiplication. So instead of divided by negative 4, it's multiplied by negative 4. What I do to one side, I must do to the other. So negative 3 times negative 4. What do we get? This cancels each other out, the division and the multiplication. It leaves me with the m. I have multiplied by a negative number, so I must flip the sign. The sign has flipped. Negative 3 times negative 4 is positive 12. I'm not sure why I'm yelling. So m must be greater than 12 for the answer to work out. Let's pick a number that's bigger than 12. I got 0. I have 12. A number bigger than 12 could be 13, could be 14, could be 15. I'm going to choose 20 because it looks like it's easy math. Let's choose 20. Let's see what happens. Let me rewrite my original equation, which is up here. I'm going to do that right there. All right, now I replace my m with something greater than 12, which is 20. So I'm going to say 20 divided by negative 4 plus 3 greater than 0. Let's do PEMDAS in the correct order now. Parentheses, do I have any? No. Exponents, any? No. Multiplication, any? No. Division, yes. 20 divided by negative 4, that's going to be negative 5, I think. I bring down my plus 3. Is it less than 0? I think it is. Then I say to myself, all right, I've done division. What about addition and subtraction? Yep, right there. Negative 5 plus 3 is negative $5 I owe somebody. And then I pay them $3. Now I only owe them $2. Is negative 2 less than 0? It is. How do I know that? Here's 0. Here's negative 2. It is to the left of 0. Therefore, it works out. And my answer is good. M should be less than 12. Pick a number that is less than 12 for m, and your equation over here will check out. All right. So here's some things we learned today. Number 1, solving inequalities is just like solving regular equations. Number 2, if you're going to divide or multiply by a negative number, you must flip the sign. And number 3, if you're going to do division, it's easier to write it out long ways so you can simply multiply it away. All right, I hope that helped. Oh, and number 4, using PEMDAS, you can go up or down depending on what you're trying to do. If you're trying to find a variable, go reverse with PEMDAS and find the inverses. If you're just trying to solve a problem, go the right way, PEMDAS. All right, hopefully that was helpful. If you have any questions, let me know. We will see you next video.